So basically what I was planning to show you today, well, the other day and now today, is basically how to spin up a router with RARE and FreeRtr, of course, but using DPDK. For that, we have basically this wonderful entry in our wiki, which is my name is Intel DPDK, and I can certainly help FreeRtr run faster. So basically, this is the first step after trying to run FreeRtr with just software, let's say. So the first thing we would like to do basically is to delegate some of the work to hardware, the hardware NICs. Okay, so assuming you are not running RARE-freeRtr in a P4 environment, a pure P4 environment, let's say a wedge or an APS switch, and you want to run it on top of a commodity server with some kind of line card, then DPDK is your option. Okay, so basically here you have an introduction of what is about that. So this is a bit the diagram that FreeRtr with DPDK will follow. So basically, what we will need is a virtual Ethernet, which will be the one connecting FreeRtr, which, as you know, is a Java-based routing software, and then the data plane, which is basically this P4MU DPDK here. This connection will be done with virtual Ethernet. Sorry, I don't know who is typing. Okay, so as I was saying, so basically we have a Java-based software which is connecting to the data plane. And what I'm going to do right now is I have prepared basically a VM here with Debian already installed, just to have this faster. And I'm going to add here to this machine already two network interfaces. Okay, this will go basically over VTO, just for the sake of doing the sorry, internet does too. So basically, I don't know who is typing so loud, but I cannot. Is it? Is it? I'm muting Christina just in case. Yeah. So basically, I have added these two interfaces. Okay, so I'm going to start the VM. So I will show you basically following the recite from Frederick how to have this DPDK working, and then we will see how we are using this DPDK in the University of Murcia, and we will then see how this and why this is important related to the section in configuration from FreeRtr, which is server P4 LAN P4. Okay. So let's go for it. Okay, so this goes here. Let's connect to the machine, hopefully. Okay, great. So basically, we have here the VM as it comes from Debian. So we are going to just I already installed the DPDK. So basically, if we do a su DPDK dev-bin -s, we see that we have 3 devices, okay, and they are already part, let's say, of the Linux stack. So basically, they are here: EMP1 S0 and EMP7 S0 and EMP8 S0. Okay, I will leave this one for basically for the connection, but we will use the other 2 ones. Okay, so these 2 ones here for our router. Okay, so I have already copied here the sources also for the sake of having this a bit faster. Okay, so what we are going to do first, we are going to flash the 2 interfaces we are willing to use. So basically EMP7S0 and EMP8S0. Okay, and then we are going, of course, to disable IPv6. In this case, we don't need it because it's going to be addressed by FreeRtr. We want the hook pages. This is quite important for performance. Never forget about this. Then we are going to use this module here just to be able to, to use DPDK with the cards. Okay, so this pretty much depends on the card you are using. You will use this module here, or you will be using others. There is BFI or PCI, which, if you remember when we did this DPDK listing, we saw that it was already here available. Then now we have this one. So this one is has been added after doing the mod probe, as you saw. So basically, we are going now to bind, okay, the two cards we want to use. Okay, so basically we do this here. Oops, sorry. But instead of this here, we are going to just copy the PCI number for our cards. Okay, so this one and basically this one. So now if we do this, we don't have EMP7S0 and EMP8S0 anymore on the Linux heap. But of course, if we check with dpdk-bin, then we see that now in a new section, which is network devices using DPDK compatible driver, we have these two cards. Okay. So now that we have this, of course, we are going to add our interface for communication between FreeRtr and the data plane. Okay, and now what we are going to do basically is to just deploy FreeRtr, which, as you know, is since it's Java based, it's quite straightforward to do. So we are going to do this, and then we are going to just copy router.jar to FreeRtr. Oops. FreeRtr lib. Okay. So we have it there already. So now we are going to install the NetTools. This NetTools package is the one that contains the DPDK binary that we are going to use to control the cards from FreeRtr. Okay. In the case of our P4 version, basically that would be the combination of the forwarder plus the P4 program that is compiled to run on top of the Tofino box. Okay. In this case, since we don't have the Tofino, we are going to have this DPDK. Okay. We are going to just extract this router.tar. Okay. In this location. So okay, so we have it there, and as you see, we have some binaries here. Some of them are already well known, but in this case, we are interested in particular in this one, okay, which is the P4 DPDK. So we are going to just create the configuration for our router, okay? Okay. And here we are going just to do this, okay? If you take a look at this, just to highlight, we have this. Of course, we are exposing the port. Let's say the configuration for the telnet. Okay, and the good thing here is we are using this pickup int, as you may know, through this virtual Ethernet that we created beforehand, just to connect this ETH0, okay, with the FreeRtr process. Apart from that, we have this p4dpdk.bin, okay, which we are passing basically as an argument the connection to the FreeRtr. And for that, we are using, as you see, as you can already guess, the configuration beforehand, okay? So through virtual Ethernet 0B. So basically, one of the ports that we will see is the one that is connecting to the FreeRtr. Okay. Okay. Now we are going to put the configuration for the switch. Okay. Okay. Let's paste it here. We have it already. So just to highlight. Okay. I think I pasted something wrong here. Okay, sorry about that. Okay, so just to highlight here, we are just defining a standard BRF. Just as you know, we always do the B1 BRF. The good thing here is we have already an export port, which is SDN100. Okay, this one, okay, this is the number of the port that we want to configure. So basically, we have on the one hand the interface definition on the top, which is in this case SDN1. Okay, and then we have on the other hand the export port for the same name. Okay, it's important, the same name, and then we put here the port. Okay. This port will be increasing as much as we are putting more DPDK cards. Okay, so basically, in our case, we will have two ports. We will have the SDN1 and the SDL2, but we don't need to just modify it here. We can do it afterwards from FreeRtr. That's not a big deal. So now we will launch FreeRtr. Okay, let me just put it here. Of course, we need to change this because we did put different names for it. Okay, router hardware and router software. I decided to use these names because basically they are the ones that come with our image. Okay, the useful ones. So now we have already FreeRtr working on the machine. Okay, and I have a small problem because I see the process restarting.
I spotted
and Saba will help me.
Yes, I spotted that in your hardware config, the path names of the processes were wrong. You are using FreeRtr with capital R, but in the hardware config you used a different name.
Okay, let me check. That's it. Yeah. That's Frederick that changed it. That. I'm joking. Yeah, and actually this is just here. This is capital R, right? Like that. That should be.
And the thing is that you are using FreeRtr while it's FreeRtr here.
Okay.
Just change the RTR to router because it's one step.
Oh, that's true. That's true. I didn't notice that. Yeah. Okay, let's go. Okay. Now it should be okay. Okay. So basically, if we do the show run as usual, Telnet local. Okay. Oops, sorry. I'm already inside. Right. Yeah. So basically, what we have in
you should press on enter because it's the Linux terminal thingy.
Yeah.
or better, just open a new terminal because it's a bit not working. And now Telnet localhost 23.
Let's do this. Localhost. Okay. Thanks God I have Saba with me. So basically, this is the configuration as I copied it. Of course, it can be changed. But the good thing is here we have exactly the same as we had in the file. Okay. And basically, when we modify this, if we go server p4 lang p4. Okay. No, first interface SDN2. Okay. And we just notch it down. Description second. space. Okay, so basically, when we modify these sections here, okay, and we do the export port SDN2, and we say it's 1, 0. Okay. So basically, the interesting thing here, if I disconnect here, maybe, yeah. What I want to show is that here, sorry, software, it has been already modified. So basically it's a file. You can, of course, backup it as many times as you want. Okay, so now, this, how do we know if this is really working? Okay, so we are going to just spin up our old or previous domains. So we have it already here, then working. So basically, we would be able to connect to these guys and start doing pinging and checking. Okay, so. Okay, so this is one of them, as this is the other one. Okay, so show run. We know that this one is connected to 10.10.10.2, and this one is connected to 10.10.10.1. So basically, if we go to our router, and let's say 66. Okay. Now we should be able to ping this guy, hopefully. And if not, I did something wrong. No. We are not receiving any packets, so
Is it the right MAC address? Or is DPDK running?
It should be.
Can you check show interface Ethernet on? Because that is the DPDK port, and that is where the packets should arrive, really, to the FreeRtr.
You mean this one?
Ethernet 0, maybe.
Yeah.
No packets.
No packets, so that's bad, right? Show processes. We can use external, and we can say for EMU it's here, so it should be okay, as far as I remember. Anyway, since I expected this happening, I have another one.
Can you show me your hardware config? I'm interested.
Yeah, sure. Yeah, that would be a pleasure.
But first of all, sudo /bin/ifconfig to see the real hardware counters on Ethernet and so on.
That's I come here.
Okay, maybe apt-get install nettools.
Okay, you want me to install nettools, right? Okay. You have it there.
Okay. Can you scroll down to virtual Ethernet?
Yeah, here we are.
Okay, no packets on virtual Ethernet 0 on receiving direction. And no packet on transmit direction on virtual Ethernet B. Now, can you show me your hardware config just to see that which is which? Okay, so
here.
virtual Ethernet B is so virtual Ethernet B is the okay, I have got it. So the thing is that you were having two DPDK physical interfaces, and the third V Ethernet B, that is three interfaces in row. And the thing is that
I know what's the problem.
the last one should be two, simply because it's the number of CPU ports starting from 0.
Yeah.
So the last one should be 2.
So basically, this one should be 1 and this one 2, right? You mean?
No, they are good. This is in the hardware config. As you start the DPDK process, that guy should know the CPU port and the last one. Yes, and it should be 2 because it is indexed from 0, and port 0 is the first DPDK, port 1 is the second DPDK, and the virtual Ethernet is the third DPDK, third pickup.
That's right. That's the MO effect, you know. The good thing is we can but we can do it from here, right? So we show another capability.
Reload warm. I have not that idea because hardware config does not reload dynamically.
Oh, okay. Then we will do it the other way. Just kill it here, run it again. Okay. Just here. Okay. And as you see, now we have some packets here. So now it's working. Okay. Right, Sava?
Yes, it should be better.
Okay. Oh, sorry, not in it. This is one. That should be working now. Okay, it's not. Oh, I did a wrong config here. No, it's okay. Should be okay. Yeah.
Okay, we have pockets. Then I think it's the MAC address. It cannot be anything else.
Okay.
Are you sure that the SDN interface's MAC address is correct?
Let me check. This is in this guy here. These are the MAC addresses here, 52, 54. Okay, so this one and this one. It's 767CB1. And if we check the MAC addresses on the...
okay, it's not matching.
Right?
Yes, it should start by 52 and it starts by 00 in SDN1.
Okay, so we can change it, right?
Yes.
Is this one here? MAC.
Without the dash. It is MAC address, but without the dash.
Okay. Sorry. I don't do it every day.
Wait a bit. And it's tricky because the MAC address is cached when you apply the VRF. So you should reapply the VRF forwarding and the address.
Okay.
Because otherwise it will use the old one.
And do I need to also put again the IP address?
Yes, we need to apply the MAC address, so the IP address also, yes.
IP4 address 10 66 255 255 255 0 and right. Think 10 1 BRF B1.
Okay, maybe still cache the MAC address. Can you restart the FreeRtr?
Of course, again.
Yes, again.
Okay, let's see. 1 BRF P1.
Still no packets.
But don't worry. So this machine has exactly the same configuration, but it's working. Because
can you show IP for ARP here? Because if you pinged it and if the packets were switched,
okay,
then it should appear in the ARP table.
Show
IPv4
ARP.
SDN1.
SDN1, right? No, not learning them.
Wait, it's a different network. It's 10.10.1.
Yeah.
Maybe it's SDN2.
Wait. Show run interface SDN1. Okay.
It's a different network. I mean,
yeah. Let me check here.
They are in different networks. It's 10.10.10 on these nodes and 10.10.1 on the DPDK guy.
Yeah, actually, let me check. So that doesn't make a lot of sense, right? Interface, yeah, okay. IPv4 address 10.10.166.255.255.255.0 and right being 10.10.1.1 ref v1. Okay, so I was putting the wrong IP address. So SDN2, forwarding v1, IPv4 address 266.255.255.255.0 and right being 10.10.2.1. BRF v1. Yeah, and it's working. Okay, so basically, as you see, even someone like me can manage to have this DPDK working. Okay, and this is basically the basis of what we wanted to show today. It's interesting, and that's why we were willing to show this. Because you can do this with almost any machine. And in this case, in the University of Murcia, we did it with a server. Okay, so basically, this is an old server, not really fancy, but it has 16 cores and it has something like 32 gigs of RAM. So basically, if you remember, we did some other labs where we had the way of tunneling with FreeRtr and so on. So basically, as you can imagine, with DPDK, with the tunneling and so on, you can use this machine, which is powerful enough to have a quite interesting configuration. And here, what I wanted to show is that basically, in this case, we have a few VLANs and a few VRFs, and of course this is even increasing every day. With this, basically we have in this machine we have two 10G ports. Okay. Oh, sorry, DPDK. Okay, this one. Oh. Come on. Okay, no worries. Okay. So in this case, okay, we have this machine with two 10G ports. This here, okay, it says 25G, but we are using them with 10G. As you see, we have different drivers here available, but we are using the BFE PCI instead of the UEO PCI generic, as you saw on the other one. And still we have also the included ports, which are 1G, and we are also using them. So this one here is being used by the operating system itself, right here. So this is how I connect it. But then NO2 is being used by the FreeRtr itself. So basically, if we connect to 2323 to FreeRtr again, we will see that in the interfaces summary, we have basically this SDN1, which is the one of the 10G interfaces that we have connected to the public interface of the lab, and then we have the SDN2 where we have our private VLANs with NAT and so on. So basically, this box can do nothing and can do a lot of things. We are using also the hairpins to provide access to different BRFs to the internet, and it's quite interesting because this is why I wanted to show you this. Here, if you look at the configuration of the ports, it's basically based on numbering. Okay, so basically we have 0 for the first interface, 1 for the second interface, 2 for the third interface, and 4 for the fourth interface. But basically, this is because I'm upgrading this. But if you do it from the beginning, you could have them, let's say, with continuous indexes, okay? But then we have a lot of zeros here that have no meaning. I mean, have no meaning here because we are not configured them. But and this is why I was wanting to show this. When you are in a before switch, okay, something like this, and you are running the image, we can provide you just to put it there. That changes a bit. Why? Because then we have, of course, we have to export the BRS as usual, but then we have the ports, okay? We have an identifier of this port, which is actually the port you have at the front of your switch. Then you have the speed, okay? And other parameters like auto configuration, FEC, and so on. So it depends pretty much on the transceiver you have put in the port. You will need to do one thing, or I mean, to put one value or the other one. So in this case, for instance, we have things like a bundle here, bundle 1, which is 228, and it's using 229 and 230. So basically, we are bundling some interfaces. I think I can show it here. Interface, bundle 1. Okay, oh, sorry, this is not the way.
What about show bundle 1?
That's it. Bundle 1, okay, for instance, run bundle 1, right?
No, it's show bundle 1, but with the space between the bundle and the 1.
That's it. Okay, so this is using these 4 interfaces, okay? And this is, on the other side, we have a standard switch, so we can, of course, bundle. We can do anything we want, as you see. The good thing is that basically this configuration, for as we were seeing beforehand, for the server P4 LAN P4, you can change it live, and that will change the configuration for the Tofino. And in the case, of course, of the DPDK, it will configure the DPDK itself. So basically, the server P4 LAN P4, and the good thing is that this is already has already some help here. Okay, so basically you just put the port number here. Let's put something random. Then you put here the speed, as I was saying. You can change. You can see if you want to do FEC or not. That depends on basically on the kind of, as I was saying, of the saver you put. Okay. So for instance, for the 100G direct attached cables, you need to use FEC. Some of them, for instance, with the finisher, it's like that. If you are using other transceivers, you may not need it. So it depends on pretty much on what you need. Okay. Then you say if you want auto negotiation or not. Then you say if you want flow control or not, and that's it. Okay. So basically, you need to for each of the ports that you want to use with FreeRtr, you need to export them this way. This will connect to the Tofino and configure it so that the ports are working. I don't know if maybe I'm speaking too much. I don't know if I make myself clear with this, and why is it so important, this P4 LAN P4? Or maybe you want to comment, Saba or Frederick?
Nothing from my part.
Okay, So basically, the important thing here is that when you have a new interface, okay, so you have to define it in as an interface here. So you just put interface SDN whatever, okay. Once you have it defined, then you need to put a BRF forwarding, as we have done several times. So here, shall run interface SDN. One, let's say. Sorry. Let's show interfaces summary. Okay. This one here, let's say, yeah. Show run interface bundle 1 210. Okay, so basically you need to put the BR forwarding as usual, okay. And the important thing while you're doing here, while you're doing that, and not to forget it, is that same BRF needs to be exposed on the P4 LAN P4. If not, it won't work, okay? First of all, okay? And then, of course, the bundle 1 needs to be also defined here, okay? Oh, no, if I missed something else. So as you see here, basically these are 4 ports, and you don't need to have the same here and here, okay? So basically this is just binding, so you can put anything you are willing to put there. And I think that's pretty much all. In this case, this box, as you see, has some BRFs. I don't know, maybe Saba wants to speak about the config in this box. Because you did it.
Yes, I remember it. So basically, we built a chain of links that way we were able to measure the full throughput of Toshiro, not the whole Toshiro, but the ports that we had there. That the lot of 100 gig SDN interfaces here, and the big numbers on the show interface summary. Yeah, but that's it. It was some measurement.
It's hardware history, right? Like this. So basically, this box, apart from managing, as you saw, some of the public traffic of the WordLab, it's also doing at the same time a small test of 100G testing. By the way, Saba, I saw that because this is running for months, but I see in the display we are limited here in hours, maybe.
I think you got an update, maybe 3 hours ago. You can check it by show platform. It should give you the uptime. Yes, it's upgrade finished, and it was.
You did it.
It was today.
Then we have to check the fire. I will say Prometheus, if we want to see it longer. But anyway, just I just wanted to show the before and not that test. So that's pretty much all from my side. I think I did it in time so that we can discuss the development of the last days. I don't know if you have any questions here. Seems not.
That was a very great presentation. I just would like to provide to add two comments. The first is that if you want to try to do the same thing in your hypervisor, depending if you have VirtualBox, vSphere, VMware, or whatever, the thing is that when you want to spin off a VM for this kind of test, you would have to make sure that the hypervisor set when you create a machine and bind a NIC to the virtual machine, you have to make sure that this interface run in promiscuous mode. Otherwise, you won't be able to do a lot of fancy things because FreeRtr has to it's a data plane port has to run in promiscuous mode in this way. The second comment is that as we discussed during the first two sessions, FreeRtr had a native socket forwarding, and so this means that FreeRtr into the same VM can communicate directly using sockets without no interface or whatsoever. The second thing is that when you want to make FreeRtr aware of available from the external world, you can use a very good tools like pkapin, or RARE-in, so that the interface can appear in your local area network. What Jordi showed you today was related to the server P4 server P4 lang stanza, and this is a very, very important configuration stanza. Basically, it is the way for FreeRtr to have it is the way to hook to FreeRtr control plane a data plane, and from this server P4 lang stanza, server P4 lang stanza, you can hook for now, 3 types of data plane. You can hook a libpcap based data plane based on libpcap library. You can hook, as Jordi showed today, a DPDK data plane, and also a real P4 data plane if you want to run your software onto a Tofino switch, sorry, P4 switch. But the key important thing is that even if the name implies that it is related to P4, basically server P4 lang stanza is here to trigger some entry creation on specific tables. These tables can take the form of table inside the P4 program. It then takes the table into the P4 DPDK software that you can look at the code here of this data plane, and it can also take the form of table into a powered by libpcap software. So this is really important because this is the secret sauce that can be used to hook any type of data plane. So imagine you have a new data plane, let's say NPL data plane or NVIDIA DPU-based data plane, for example. If there is a slight difference in compared to P4 Tofino, we can think about sending strictly the same message, and it will create the relevant table when you program the data plane. So this is quite important. We have a bit of time, 10 minutes. So what I would like to show you is, some of you might already know this demo, but this is mainly for Carmen, who is here with us today. And I would like to show her. Can I show my screen, Jordi?
You should be good now.
Okay, so thank you, Jordi. So I wanted to show you this demo, especially for Carmen, simply because Xaba did recently a great deal of development related to traffic engineering, and I'm not sure if Carmen was aware of that. So I wanted to hammer the fact that this is already a reality. Here, in this case, we will take the example of the existing P4 switch in Europe, one in the Amsterdam, Poznan, Budapest, Frankfurt, well-known square. And we have 2 bare metal server that is injecting 7 gig of traffic. Actually, it's running Cisco tracks using DPDK. And the second server connected to Frankfurt will be here to receive. So we will send this traffic. And as you see, Carmen, it is taking the longer path. Whereas the IGP says that in order to reach this server from Amsterdam, you need to reach this shorter path. Okay, so this is not the natural path. This is So let me try. This is again the demo effect. I don't have any parachute, so if it doesn't work, sorry. I'm kidding, Carmen. So let's try to run the traffic, okay? It's something fun. So the traffic is launched, and you will see that we are starting to send 7 gig of traffic. Is it okay, Carmen, for you? Yes, okay, I see you nodding. And the good news is that here you see that the second server is receiving 7 gig. So what does it mean? It means that here we pour into the network 7 gigs, and this one is receiving 7 gig, which is great. This is what we want. Now let's have a look at the path. So if we want to look at the path, let's go first to Amsterdam. This is the Amsterdam P4 switch, because you had a question last time. How do we monitor the fact that the packets are going via this interface or this interface? So let's try to unselect all, to select only the interface that are interesting. So let's do SDN1 and SDN2. And as you will see, here, Carmen, we are receiving traffic from the, we are receiving. So you see, there's we are receiving traffic from the DTN. And of course, this is from the last minute, but it will ramp up sooner or later. So we are receiving some kind of traffic here, and we are sending it to SDN2. SDN2, if you recall the picture here, SDN2 is going to Poznan. If I go to Poznan, you have to believe me by heart, because of course Poznan has this IP address. If I'm going to Poznan, you see that in SDN2, I'm receiving the same amount of traffic, and I am transmitting back to SDN1. This is the TX here. And if I'm cheating, I have a cheat sheet. SDN2, I'm receiving 7 gig here, and I'm sending 7 gig at SDN1. So I'm sending to Budapest. Let's go to Budapest. In Budapest, we are receiving in SDN1, and we are transmitting to SDN2. So again, I'm receiving 7 gig here. So what does it mean? It means that I'm pretty sure that Frankfurt will receive some kind of traffic at SDN2. So let's go ahead and check it all together. I think it's this one. So I was right. So SDN2, Frankfurt is receiving this kind of traffic, and it is egressing somewhere. Let's see. It's egressing at SDN 3.101, which is actually this server. And this is confirmed by what we are seeing here. Sorry. I am on the second server. Sorry, I am on the second server here, and I'm receiving 7 gig, which is what we want. So what is the magic here, Carmen, for you, is that this traffic has IP identifier 120, or what you can call flow label. So this traffic has flow label 120. Now what's happening if I stop the traffic? Okay, so no, first of all, I want to show you something. If you are going to Amsterdam, let's go to Amsterdam. There is something called policy-based routing. This policy-based routing is saying that we are doing a policy-based routing with IPv4 traffic in a VRF called core, and all the traffic that match this access list will have next up 10, 11, 22. So if I look at what is 10, 11, 22, we see that it is tunnel 1 to 2. So show run interface TU. Sorry. You see that this is actually Poznan, Budapest, and then it's going back to Frankfurt. So this is the tunnel end. So this is what we wanted. So all of this is working simply because we put the identifier 120. Okay, so now let's stop the traffic and put 121. of course, 121 doesn't match this access list. You see, this access list match only flow 120 and not 121. And here we are sending traffic 120. So Carmen, if you are understood, of course, the experiment, what will be the result?
It will take the short path, no?
Exactly, exactly. Now, this is again the Debo effect. I hope that it will work because Xaba, do you think it will work?
I am checking on the console and I already see that the traffic reverted.
I knew that you were trying to inflate. No, please don't try to accelerate the process.
No, I didn't configure anything. I just checked the interface counters.
So why this is important, Carmen? It's because you can do traffic engineering on source routing using RSVP tunnel on a backbone. And this is, and again, for now, this example is intra-domain. So we are running in an IGP and we are receiving traffic into the same domain. Of course, the idea is to push this at the next level and see if we can do this based on customer traffic via layer-free VPN, VPLS, TVPN, and with SODA. But why I'm still talking is simply because I wanted to gain some time in order to show you that the graph is going down. So it's going down here. So what does this mean? We are in Frankfurt, it's going down. So what? But the traffic, but Cisco Trex is still saying that he's receiving traffic. So if it's going down somewhere, it must go up somewhere. And it is going up at SDN1. So what does it mean? It means, Carmen, that you are totally right. It's taking the shorter path. The good news is that we can do also this with IPv6 flow label. And I will be truly honest with you. I did not test it yet, but we can test it not today because we have 3 minutes. But this is this is just to show you that this is the reality. I will stop the traffic in order not to overwhelm the backbone, but 7 gigs is not that much. But this was an existing example for you. What is important also to note is that whether you have a P4 switch, whether you are using FreeRtr with DPDK, you can create 4 servers, for example, 4 VM, and connect them as the backbone. This will work. This traffic engineering will work because I think that Xaba push the code to every data plane like DPDK, P4,
yes,
EMV2, and so on. So you are not forced to have P4 data plane equipment. You can play with it with FreeRtr using DPDK. This is why what Jordi showed you today was very important. It's simply because if you want to test it with 4 VMs with DPDK and so on, you can do it without having the P4 switch. Closing the loop with Christina now. The idea here is to be able, here we are creating a tunnel that is explicit, that is static. But this tunnel can take the form of a route ID computed with node ID using Polka. And from that point, I will leave the floor to you, Christina, and also if you want, Manios, if you want to jump into the discussion, and Xaba related to that, because maybe you have some ideas on that.
Thank you very much, Frederick and Jordi. Very nice demonstrations. Thank you. From our side, some updates. So the translation of our Java code, it's almost finished. We just need to run some final tests. We are on some hard deadlines. I hope I will finish that by the end of the week. Then I send that to Xaba. Xaba also sent us an email with some suggestions very nice suggestions regarding the TTL and the rewriting of the Ethernet address. So he already worked on some solutions. Thank you, Xaba. I have just replied to his email saying that I just have to study a bit more to realign some of the arguments we used in the paper. So I want to understand if we can do something to still keep some naive arguments that we have in the paper, but to put that in production and in a way that it's we can guarantee the interoperability with the standard protocols. So I think Xaba has helped us a lot with these suggestions, and we now have to just study a bit, understand a bit more about the FreeRtr environment. But I think we are going very well with the great support from Xaba. Magnus, do you want to add something? Magnus is also joining the meeting.
Yes. Thank you, Christina, thank you very much for the collaboration with Xaba. Has been very productive for us, and he made a lot of comments. As Christina said, yeah, sort of mechanism to avoid a loop in the network. So this kind of thing, but our discussion internally is because of the proposal was more without rewriting things. So this was the basic things, and making the connection. Maybe one more useful comment is the connection between the previous demonstration of Frederick with this label that, if I understood correct, has been previously created. So in case of Polka, we can make these, let's say, traffic engineering at the source without making this pre-configuration, I suppose, at the edges, at the nodes. So this is something that it would be nice. I think it has been demonstrated a little bit, Christina, in our ONDM paper. Yeah. And but it's nice to make this connect with Carmen, Nisa. Also, this, I mean, Polka has this flexibility. Another point I think was from Xaba, were more related not only to the TTL but also to the rewrite in terms of Ethernet header. Yes, I think he is correct. Actually, we tried to use, or we tried to think about the virtual max. Christina, well, we need to think a little bit more in order to take your comments into consideration. And I would like to, I mean, I'd like to hear a little bit more something that you said about the benefits of Polka when we said that we can express longer paths in comparison with segment routing and more, you said, more real commercial here. And this time,
this is a limitation of the segment routing protocol.
All right.
So,
yes. All right.
So you have a maximum number of hops that you can include.
It is a limitation of most commercial gears, so so they cannot impose any number of labels. Smaller boxes have a small number, such 4, and the biggest box I have seen is 8 at this category. And if I saw your paper with the 820, sorry, with 128 bits, you can express even more nodes. So it's Polka is outperforming the segment routing already.
So Magnus, if you look at the P4 library from Barefoot, they even have even the P4 Long Consortium invented an object called VARBit. And VARBit has a strange behavior because it was said from the start that in P4 that everything was static. And for example, if you have an MPLS header, you have to, in your program, to hardcode the size of the header. You say,
yes.
In our case, for example, we have a header that We don't have, we have mimicked the header behavior, but in the sense that we have two levels of label. But if for segment routing, you have this unknown label stack size that is represented by this new object barbit. And the good thing with Polka is that you don't need this. You don't need the label stuff because everything is computed via the modulo, the modulo operation, the CRC modulo operation, and in a sense, you don't have the hardware for that. And this is a real key strength for that, a real key strength. And the idea is that this is why I also wanted to suggest you to start and initiate all. We can do this all together. Again, I am reiterating the proposition to initiate a draft in the ETF. Emphasizing this hardware comparison, and this is a great things that that Xaba could mimic it, because in P4 the hardware is so generic that you can't afford to have an infinite amount of an infinite size for the header, and and this is where we stand.
Yeah, that's very good point. Yeah, when I was in the beginning, when I was implementing the proposal in BMV2, we were comparing with some list-based approaches as segment routing, and we had that problem because of the var header implementation in P4. So it's something that it's from our point of view, because we were trying to push this idea ahead, we have some arguments, and we know some of them are weaker and other are stronger. For example, we have this fixed header, we have the operation reusing the CSC, so it's done in hardware, but some of them, when we go to production and we have to be to have this interoperability with the other protocols, some of them I'm still not sure if we should focus on them to strengthen the benefits of the proposal. So that's something that I'm the email from Xaba make me think if we are pushing if our arguments are really the best to push the proposal ahead. So there are some benefits. We know that there are some benefits, but maybe we are focusing on the wrong ones.
Xaba, maybe you have opinions or suggestion? Of course, I think you will be on board with us if we write this draft.
No new suggestions. I already written all my ideas.
Yeah, but I really appreciate your comment, Frederick and Xaba, because of course you are on board and you have a previous or more experience, much more experience, not only on the implementation side, but the more in the interoperability and in how other standardized protocols are working. So your participation, your point was really good. You know, as Christina said, we need to focus on the right side in order to make a draft or something like that. And we need, guys, we need your help, definitely. So thank you for the support, and we go forward with you guys.
Yes, it was just a coincidence. I sent a link in the chat. This week I received a call for papers for a conference that is related to standards. I didn't know this conference, but the deadline is too short. But I think the Frederick's idea to write a standard, it's a very nice way to go.
That's great. So, Carmen, any final words from your side? Italo or Alan, are you following us with this? Because this is a pretty really service provider topic. I'm not sure if you you are very aware or interested in this. But anyway, no, Karen?
No, I was following you, so no problems. But I don't have any updates.
Yeah, sure. But I mean, what about the progress that have been done? Do you think that it will? The next step would be to activate the same functionality on the P4 switch on the wedge, and maybe activate this also using the CERN light that is part of the auto goal that is already connected to all the open light exchange in the world. And when they can try to benefit from the 100 gig path and do some traffic engineering between maybe tier 1, tier 2 data computing center in the LHC or over research community. So we are close to do something real, and maybe next step is to test the same thing with IPv6 then. But same problem with IPv6, we will have this extension header that we will pile up at some point.
Okay, perfect. Just let me know.
Okay. So thank you all for your time. And again, thank you, Xaba, for everything.
Thank you. Frederick, just one question regarding how we should proceed to write the draft for the standard. Do you think we should write something and then share with you? Do you have any idea?
Okay, if you want, the idea would be to mimic the existing structure of the existing draft. There is some RFC already indicating how to submit draft. So maybe we can maybe for example, if you want, because you are really the originator of this very brilliant idea, maybe what you can do is to start the draft using this recommendation, and then we can circulate and all together and correct things. Is it okay for you, Xaba, to work like this?
Sure.
So that's great. Of course, what we will, in our case, we will try to focus on make Polka into a real use case into production. The idea is to really try to make it enter the network we practically, and not being something fancy that it just was. Again, the idea is to highlight the pros and cons. I see some cons already, but these are most outside the network. Actually, or the route ID computation, or and how to add along to add nodes along the life of the network can change things. So maybe we will have some. Maybe the external systems might be more complex, but again, this is if the benefit is to have something implementable into the hardware with more, I would say, longer paths compared to technologies that I'm pretty sure that having a 10 label burned out into silicon has a cost. I'm pretty sure. Yes. So that's the idea. So, anyway, thanks to all for your availability. I hope it was interesting for everyone. Sorry, we have crossed the 1 hour session by 13 minutes, but I think it was really great to have this discussion, because the idea of this session is not only for us to provide you some hints and insight on how to do things, how to do that, but also to communicate and how we can exchange ideas and how we can make this evolve all together. And I see you, and I hope to see you soon then, maybe in person, maybe at some point, in 1 year, or maybe next year. But meanwhile, I suggest we talk that next week for the next session.
Thank you very much.
Perfect. Thank you.
Bye-bye.
See you next week.
Bye.
Bye.
Thank you, guys.